This is Chapter 7 of our AZ-204 preparation. We now focus on integration with third-party services and external APIs. While Azure provides many built-in services, real-world applications almost always connect to outside systems such as payment processors, social media platforms, CRMs, or custom APIs. Why is this important for the exam? Because developers must know not only how to use Azure services, but also how to securely consume and integrate with services that live outside Azure. Mini review. Third-party integration equals REST APIs, authentication, resilience, and secure handling of secrets. What is the standard way to connect to third-party services? Through REST APIs, using HTTP methods like GET, POST, PUT, and DELETE. What tools are used in Azure applications to call REST APIs? The HttpClient class in Net, the request library in Python, Fetch or Axios in JavaScript, and official SDKs when available. What must you consider when consuming APIs? Endpoint URLs, authentication tokens, headers, request bodies, and error handling. Mini review. Consuming APIs equals making HTTP calls with authentication and handling responses properly. How do third-party services usually authenticate? With API keys, OAuth 2 tokens, or client certificates. How should these credentials be stored? Always in Azure Key Vault or in environment variables connected to managed identities. Never hardcode secrets in code. What is OAuth 2? It is an industry standard protocol for authorization. It allows apps to obtain access tokens after user consent or client credentials. What is the difference between API key and OAuth? API keys are simple but less secure. OAuth provides delegated, time-limited, and revocable tokens. Mini review. Authentication equals API keys, OAuth tokens, and secure secret storage. Why is resilience important when calling third-party services? Because external APIs may fail, throttle, or respond slowly. What patterns should you implement? Retry policies with exponential backoff, timeouts, and circuit breakers. What Azure library supports resilience in Net? The Poly library integrated with HttpClient Factory is a common choice. What exam scenarios can appear? You may need to recommend retry logic for an unstable external API. Mini review. Resilience equals retries, timeouts, circuit breakers, and fault tolerance. How do you secure integrations? First, by storing credentials in Key Vault. Second, by using managed identities when possible. Third, by ensuring HTTPS connections for all API calls. What about data privacy? Mask or encrypt sensitive information before sending it to external services. What about logging? Log request results, but never log sensitive credentials or payloads. Mini review. Secure integration equals protected secrets, encrypted connections, privacy, and careful logging. Example 1. Payment processing with Stripe or PayPal. Applications must handle tokens securely and follow webhooks for payment events. Example 2. Social media integration with Twitter or Facebook APIs. Apps must authenticate with OAuth and manage rate limits. Example 3. CRM integration with Salesforce APIs. Apps must handle authentication tokens and batch requests efficiently. Example 4. Messaging integration with Twilio or SendGrid. Azure Functions can trigger SMS or email workflows securely. Mini review. Third-party services appear in payments, social media, CRM, and messaging. Scenario 1. A function must call a weather API every hour. Solution. Use HttpClient with a timer trigger, store API key in Key Vault, and implement retries. Scenario 2. A web app must integrate with PayPal for checkout. Solution. Use OAuth tokens stored in Key Vault, call REST APIs securely, and handle payment webhooks. Scenario 3. A serverless workflow must send emails. Solution. Use SendGrid binding in Azure Functions with credentials in Key Vault. Scenario 4. A mobile backend must allow users to log in with Google accounts. Solution: configure OAuth integration with Entra ID as an identity provider. Mini review. Scenarios prove you must combine authentication, secure secrets, and resilience when consuming external APIs. Best practice 1. Never hardcode API keys or tokens in your source code. Best practice 2. Use Key Vault and managed identities for secret management. Best practice 3. Always implement retry logic and backoff for external calls. Best practice 4. Respect rate limits of third-party services and design accordingly. Best practice 5. Monitor and log external API performance to detect outages early. Mini review. Best practices equal secret security, retries, respecting limits, and monitoring. What tools help with third-party API development? Postman for exploring endpoints, Fiddler or Wireshark for inspecting traffic, and Swagger or OpenAPI documentation for understanding API contracts. What Azure tools help? API management can proxy external APIs, add caching, or apply policies to improve reliability and security. What about testing? Use mocks or stubs when external APIs are unavailable during development. Mini review. Developer tools equal Postman, API management, Swagger, and mocking frameworks. Review time. Third-party integration is part of the integration domain in the exam and is critical in real projects. Consuming REST APIs requires HttpClient or SDKs with correct headers and payloads. Authentication is handled with API keys, OAuth tokens, or certificates. Always store them in Key Vault. Resilience requires retries, timeouts, and circuit breakers to handle failures. Security means HTTPS, encryption, secret protection, and careful logging. Common external services include Stripe, PayPal, Salesforce, Twitter, SendGrid, and Twilio. Scenarios demonstrate that secure, resilient integration is necessary in payment, social, CRM, and messaging use cases. Best practices: no secrets in code, implement retries, respect limits, and monitor APIs. Final message: a skilled Azure developer can connect Azure applications to any external service while keeping them secure and resilient.